Ever wish there was a shortcut to solving like really complex problems? Finding the absolute best solution out of a ton of possibilities. Turns out there might be, and it involves parallel universes.
Really fascinating how theoretical physics can spark innovation in like the most unexpected places.
Yeah.
In this case, it's led to a brand new algorithm called MVA,
Okay.
designed to tackle, some of the toughest challenges we face.
So we're diving into this research paper today, but first, can you maybe just give us a quick breakdown? What even is an algorithm in this context, and what makes this one so special?
Sure. So think of an algorithm as like a set of instructions for solving a problem. It's like a recipe. It takes you from a set of ingredients to a finished dish.
I like that.
In this case, the dish we're trying to create is the best possible solution out of like a huge number of options. We call this an optimization problem.
Okay, so it's like having a roadmap to find the perfect solution. But what makes this algorithm, this MVA algorithm, different?
Well, most algorithms take inspiration from things we see in nature, like how ants find the shortest path to food, or how birds flock together.
Right.
But MVA, this one's inspired by the multiverse theory.
Whoa, okay, the multiverse theory.
Yeah, the idea that there are countless universes existing alongside our own. Each universe is slightly different,
Okay.
like a variation on a theme.
So how does that tie into solving problems? How can you use the idea of multiple universes to find solutions in our universe?
That's the ingenious part.
Mm.
Imagine each universe as a testing ground for different solutions. MVA starts with a set of potential solutions. And each solution is like a separate universe with its own set of possibilities.
So it's like each universe is running its own experiment, trying to find the best answer.
Exactly. And then things get even more interesting. The algorithm simulates an explosion of solutions. Just like the Big Bang created our universe, each of these solutions explodes outward, branching out into even more possibilities.
Oh, wow.
This lets MVA explore a vast range of options, far more than traditional algorithms.
So it's not just about having multiple universes. It's about those universes rapidly expanding and evolving to find the best possible solutions. That sounds incredibly complex. Does it actually work in practice?
That's the exciting part. The researchers put MVA to the test on some classic optimization problems. For example, they used it to tackle the Ackley function.
Okay.
It's a mathematical problem that's known to be difficult to solve.
Right.
MVA managed to find the absolute best solution in just T2BO iterations.
2 iterations, that's unbelievably fast. Most algorithms would take way longer to find the optimal solution, right?
Absolutely. And it gets even better. They also tested it on the Holder table function.
Okay.
This one is even trickier because there are multiple optimal solutions.
Yeah.
And MVA successfully pinpointed one of the hardest ones to find, again, in just 2 iterations.
So it's not just finding a solution, it's finding the very best solution out of multiple possibilities and doing it incredibly quickly. This is really impressive.
And they didn't stop there. They even tested MVA on what's called a bi-level programming problem.
A bi-level programming problem.
Yeah. These are essentially like solving 2 optimization problems at once, nested within each other.
Wow.
Think of it like a puzzle within a puzzle.
Okay.
These are notoriously difficult. But MVA found the same solution as traditional exact algorithms, but much faster.
Okay, my mind is officially blown. So we've got an algorithm that's inspired by the multiverse theory. It explores solutions faster and more effectively than traditional methods, and it's already showing amazing results. Where could this lead? What kind of real-world problems could this solve?
The potential applications are truly vast. Imagine a world where traffic flows smoothly in our cities, where energy grids are managed with incredible efficiency, and where logistics and transportation systems operate flawlessly. MVA could help make that a reality.
I'm starting to see how this could be a game changer in so many fields. Let's dive into some specific examples in those areas and see just how powerful this algorithm could be. Okay, so we've got this algorithm. It's inspired by the multiverse theory. It's finding solutions faster, better. But where do we actually APPLY something like this? What would that even look like in the real world?
Well, let's take smart cities, for example.
Smart cities, okay.
Imagine, a city where sensors and cameras are constantly feeding information about traffic flow to a central system.
So like a digital nervous system for the whole city.
Exactly. And MVA is like the brain, analyzing all that data in real time.
Oh, I see.
It could dynamically adjust traffic lights to ease congestion, optimize routes for public transportation, even guide self-driving cars to prevent accidents.
So it's not just about making traffic lights faster.
Right.
It's about creating a truly intelligent
Yeah.
transportation system that adapts and evolves in real time.
Precisely.
Yeah.
And the benefits extend beyond just, saving time.
Huh.
Think about reducing pollution, improving air quality,
Right.
creating quieter and more pedestrian-friendly streets.
That seems amazing. But what about something like energy grids? Those seem even more complex to manage.
Energy grids, those are a perfect example of where MVA could really shine, I think.
Yeah.
These systems need to balance energy supply and demand constantly,
Yeah.
which is, becoming even more challenging with the rise of renewable energy sources like solar and wind power.
Because the sun isn't always shining and the wind isn't always blowing, right?
Exactly. So MVA could analyze data from, weather forecasts, energy consumption patterns, even individual household usage, right? And then optimize energy distribution.
It's like having a super intelligent conductor orchestrating the entire energy symphony, making sure everyone has power exactly when they need it.
That's a great analogy.
Yeah.
And think about the potential for reducing waste and lowering energy costs.
Yeah.
MVA could help us transition to a more sustainable and efficient energy future.
Okay, I'm convinced. MVA could be huge for energy. But what about industries that rely heavily on logistics and transportation, like shipping and delivery companies?
That's another area where MVA could have a massive impact. Imagine a company like Amazon, with thousands of delivery trucks on the road every day.
Right.
MVA could optimize delivery routes in real time, taking into account traffic, weather conditions, even fuel efficiency.
So instead of relying on like static routes planned in advance, MVA could dynamically adjust those routes on the fly to make sure packages are delivered as quickly and efficiently as possible.
Exactly. And that's not all. It could also help companies manage their fleet of vehicles, schedule maintenance, and even predict potential disruptions, like, before they even occur.
This is starting to sound less like science fiction and more like the future of how we do business. But I'm curious, are there any areas where MVA might not be the best solution?
That's a great question. Remember, MVA thrives on data, problems with a vast number of possible solutions.
Right.
So situations with limited data or a small set of options, those might not be the best fit.
It's like trying to use a rocket launcher to swat a fly, right?
Exactly.
You need the right tool for the right job.
Exactly. But even in those cases, MVA could still be used in conjunction with other approaches.
Okay.
It's not an all-or-nothing solution.
So we're talking about a powerful tool that could be applied across a wide range of industries and even like everyday life.
And the exciting thing is we're only just beginning to explore the possibilities as we develop more powerful computers, gather more data, and refine the algorithms themselves. Who knows what we'll be able to achieve with MVA?
Okay, I'm officially on board the MVA hype train, but I think it's important to acknowledge that with any new technology, there are always potential downsides or challenges to consider.
Yeah.
What are some of the hurdles we might face in, actually realizing the full potential of MVA?
Yeah, for sure. I mean, as we've touched on already, one of the biggest challenges is computational power. MVA needs a lot of computing power,
Right.
to simulate all those exploding universes and evaluate all the countless potential solutions.
Sure.
It's like trying to, run a supercomputer on a smartwatch.
So even with all the amazing advancements we've made in computing, we're not quite there yet.
Not quite. We need faster processors, more efficient algorithms, and maybe even like completely new ways of thinking about computing to truly unleash MVA's power,
So we need a hardware revolution to match the software revolution that MVA represents.
Yeah.
That makes sense. What else? What else stands in our way?
Data.
Okay.
MVA is a data-hungry algorithm. It needs vast amounts of information to train and refine its models.
Right.
And in many real-world situations, that data is either scarce, fragmented, or difficult to access.
It's like having a high-performance race car but no fuel to put in it.
Exactly.
So even if we had all the computing power in the world, we still need to figure out the data piece.
Right.
What can we do about that?
Well, there are a few, I think, key areas we need to focus on.
Okay.
First, we need to invest in, more robust and efficient ways to collect data.
Right. It's all about building that digital nervous system for our cities, our infrastructure, even our daily lives.
Exactly. Second, we need to prioritize data privacy and security. People need to feel confident that their data is being handled responsibly, ethically.
That's crucial, especially as we're gathering more and more data about individuals and their behaviors.
Absolutely. And finally, we need to create systems for sharing data openly and transparently.
Yeah.
This will allow researchers and developers to collaborate more effectively and really accelerate the pace of innovation.
So it's not just a technological hurdle, it's a social and ethical one as well.
Right.
We need to figure out how to gather and use data in a way that benefits everyone while respecting individual rights and privacy.
Couldn't have said it better myself.
Now, you mentioned interpretability earlier.
Yeah.
Can you explain that a little bit more?
Sure. So MBA can produce incredibly complex solutions, but sometimes it's hard to understand how it arrived at those solutions.
It's like getting the right answer on a math test, but not being able to show your work.
Exactly.
How do we trust the results if we don't understand the reasoning behind them?
That's a great point. We need tools and techniques that can help us make sense of these complex algorithms. We need to be able to peer inside the black box and understand the logic behind the solutions. This is an active area of research in the field of artificial intelligence, and I'm confident we'll make significant progress in the coming years.
So even though there are challenges to overcome, it sounds like there's a lot of excitement and optimism about the future of MBA.
Absolutely.
Imagine a world where our cities are smarter and more efficient, where we do have access to personalized healthcare and education, and where we can tackle some of humanity's biggest challenges like climate change and resource scarcity with new tools and insights.
It's a future worth striving for sure. And even if MVA doesn't solve every problem, it's pushing us to think differently, to explore new possibilities, and to challenge the boundaries of what we thought was possible.
I love that. And on that note, I think it's time to wrap up our deep dive into the multiverse algorithm.
It's been a journey.
It has been a mind-bending journey, full of incredible possibilities and thought-provoking challenges.
Yeah, it certainly has.
So to our listeners, thank you for joining us on this exploration of the multiverse algorithm. And remember, the most groundbreaking solutions often come from the most unexpected places. Keep exploring, keep questioning, and never stop learning.
And who knows? Maybe someday you will be the one developing the next revolutionary algorithm that changes the world.
Until next time, stay curious.